Hello everyone, hope you all are doing well. So in this video we'll discuss another linked list related problem. If you are new to this channel or this playlist, then we started with this Leetcode crash course, that data structure and algorithm crash course that we were having. But then we finally shortlisted some more problems related to linked list. We have started with linked list topic, and we have selected these 22 problems related to single linked list and double linked list, and we are solving each one of them one by one, seeing the intuition of each one of them and how to approach these type of problem, right? So that's what we are doing. We have already solved some of the problems, and now we will be moving to the fifth problem: swap nodes in pairs. So let's go to the problem statement. So problem statement says that given a linked list, swap every two adjacent nodes and return its head. You must solve the problem without modifying the values in the list node. That is, only nodes themselves may be changed, right? I'll also tell why basically the problem says why the problem emphasizes that you cannot change the value of a node, right? That also we'll see, right? So first try to understand the problem statement. So suppose, just a second, yeah. So suppose this is my list, 1 2 3 4. This is my list. It says swap the nodes in pairs. So swap these two, then swap these two. Suppose there would have been one more node, so it is not forming a pair, right, with anyone else. So you can't swap it. So it becomes 2 1. These two are swapped. This will point to 4, this will point to 3. These two are swapped, and then this will point to 5, and then finally we have null, right? So this is the final thing that we want, right? So yeah, a basic implementation based problem. I'll tell you how to approach this one. But just one more thing: the problem said that you cannot modify the values in the list. Now why that is said in the problem? So actually each node here has two things: data and a pointer to the next node. Not pointer, yeah, it basically points to the next node, keeps an address, keeps a reference, whatever you want to say, but somehow it keeps a track of what is the next node. Why I'm not using the word pointer? Because Java guys will feel that okay, there is no pointer in Java, so that is why it just keeps a reference of the next node that is just present after that, right? And data, now data can be huge, right? Data can be a single value, right? Data can be a class object, data can be a collection of values, right? So suppose there are two nodes, node 1 and node 2. Now if I want to remove this node, right? If I want to remove this node, or just consider that I want to copy the value of n2 in a temp node, right? So now what will happen? There is a possibility that the data that is present in this n2 is pretty huge, right? It contains a lot of data, and when you try to copy it into another node, then that's an expensive operation, right? That's an expensive operation, copying multiple data values. However, if you just change the reference, right, if you somehow just change the reference, then that is a, I would say, single op operation, right? That's just one step, that you just change the reference from one node to another node, and then we are done. So that is why changing references is a relatively less expensive operation as compared to copying data from a heavy node to another node, right? Because the data types in all the nodes will be same, right? This is homogeneous data. So that is why it says that you just modify these links and do not change the values. Like for example, another possibility here would have been that so you have one and then you have two. What you can do, similar to two variables, you take a temp variable and then you store it. In this you store one, then here you put one, and you swap it using a variable. But again, what you are doing here, you are doing multiple copy operation, and that can be expensive. And what we will be doing is we will be changing the references somehow, and we'll be seeing how to approach this type of problem, right? So yeah, that was the main thing I wanted to explain you. Now let's see how to approach this problem, right? 1 2 3 4 and 5. I'll take 5 notes because we'll just take the complex case in the first go only, right? Null, right? Now as I have told you that in most of the problems, what I do, I add a dummy node here. You'll see here also what's the utility of the dummy node, right? Now what I can do is remember I need to swap this and I need to swap this, right? So and I need to do this in place. I cannot use any extra space or something like that, right? So ultimately what I want is, let me just change the color for clarity. What I want is that this pointer points to this, right? This pointer points to this, right? Right? And this pointer points to 2, right? Because this is the dummy node. After being swapped, this pointer should point to 2, 2 should point to 1, and 1 should point to 3, right? So that is why 1 will point to 3, right? 2 will point to 1, and this dummy pointer will point to 2, right? And then I'll tackle these two nodes, right? So that is why just see here that I took a dummy node, right? And so in every case, suppose I consider these two. After these two, I have this pointer. This is not the first node which I need to tackle. So that is why I have taken an extra node here, so that the cases are similar. Whichever pair you take, you have a node before that. So handling the pointers and avoiding the null checks become very easy, right? So that's the basic case. Now how I can do it, you have seen what we need to do. Now doing this stuff is very easy. I'll if I just go for a sort of pseudo code or the approach, then all you need to do is let's call it first, right? First will be here head, right? Now remember, what is head? This is head. This is dummy, this is head. Head is the first node of the pair that we are targeting. Now what is second? Second is head dot next. Obviously we'll be running this in the loop with a check that while head is not equal to null, right? And head dot next is not equal to null, right? Simple stuff. Otherwise if this is equal to null, then you have even number of nodes, you are done. If this is equal to null, that means you have odd number of nodes, and obviously the last one cannot form a pair, right? Simple stuff. So you take first equals to head, that means your first will point here. Let me just change the color for clarity. Let me take green. So your first will point here, your second will point here, right? Now what happens? Now the first thing that you need to do is you need to make this one point to 3, right? Make this one point to 3. So that means this is the first node. So you make first dot next point to second dot next, right? This is second and this is second ka next. Simple stuff. Now second ka next should point to first. Second dot next should point to first. Basic stuff, right? Now what you need to do, right? Now what you need to do, just see here that now my target will be that suppose I take a variable temp also here. Why I need it? Because dummy will always remain the same, so that I at last I return dummy.x, and this is the variable which tells me which pair I am targeting, right? So like initially temp will be here, then temp will move here, then temp will move here, and so on, right? Simple, a temporary variable. Now what I'll do, the temp dot next, initially just a second, initially temp will start from, I told you now we need to avoid null check, so temp will be here and temp will not be here, temp will be here and temp will be here, not here. Why? Because we want temp, the next of temp, to also change, right? So we need a variable here, because we want this pointer to change. And suppose this is node 1, this is node 2, right? If you want to change this pointer, you need a pointer here, right? If you want to change this next, you need a pointer here. So that is why we need a temp here, right? So what we'll do, initially temp is here. Now I need to change, I want that temp ka next should point to second. Remember, second is 2, right? Now head was pointing to 1. What I'll do, head equals to first dot next, right? head was this, now it has moved here, so head should move here, right? Then the starting of the new pair, and then I'll do temp equals to first. Simple, right? Let me just tell you once more. This is the dummy node, this is 1, this is 2, this is 3. Temp is here. Why? Because I want to modify this pointer as well, right? So in the first step, what we are doing, and let's call it first, let's call it second, right? So what I am doing, first I am doing, let me just change the color for clarity. Yeah, I'll pick this color. First step, that this pointer goes here. This is the first step. Second step, this pointer goes here, right? Now the third step, this pointer goes here, right? Now what has happened, this is D, this is pointing to 2, 2 is pointing to 1, 1 is pointing to 3, right? This is done. My list has been modified. Now what I need to do, I need to, now initially temp was here because I wanted to process these two nodes. I need my temp here now, sorry, I need my temp here now. So what I'll do, I will and head was here, right? Head was here. So just remember, head was the first node which I want to process, so head should move here. So that is what I've done. Head equals to first dot next. This is first, remember the name of this is first, this is second, right? And then what I should do, I should make temp equals to first. Temp should come here, right? Simple, basic stuff. Forget about what I've done here, forget about this, just see what's the logic here. How do I need to rearrange the pointers, and then this code is very simple to write, right? Yeah, that's it what I wanted to tell. I hope you understood this thing. Let's jump into the code. So yeah, as you can see, exactly the same thing that I've been telling you. I take a dummy node on line number 13, I do dummy.next equals to head. Then I take a temp variable as well pointing to dummy because I want to avoid null checks and all. On line number 16, I have while head is not equal to null and head.next is not equal to null. This is for checking that the node should occur in pair. If I get an odd one out, that means if the total number of nodes is even, that means I'm left with no nodes. If the total number of nodes is odd, that means I'm left with just one node. So that's the basic crux why I do this check. And on line number 17, again I take first, I take second, and as I told you, first dot next will point to second connects and all that, all the stuff that I told you in the pseudocode, and finally we'll return dummy dot next, right? So yeah, this is again, target of this channel is not to crack the interviews, but becoming a good problem solver. Cracking a mang company or any company will come as a byproduct, right? So but then also, this is one of the majorly asked problems in big companies and tech giants. So I wanted to emphasize on the logic, because what happens now, I have seen candidates when I take interviews, that what happens, they try to mug up this solution and they somehow reorder these statements because they learned it, right? They do not understand it. So that's why I wanted you to know the logic of it, and not basically just see that, okay, this is the first line, this is the second line, and so on, right? The simplest way to solve a linked list problem is just make a diagram. Make a diagram like this. I know my handwriting is bad, but make a clean diagram and see how you need to rearrange the pointers, and that will become super easy, right? So yeah, that's how I solve the linked list related problems. So yeah, I hope you learned something new from this video. Do let me know in case you have any queries, and we'll be solving more and more complex problems at the end of this playlist. Trust me, almost all the topics, all the, I would say, different variations of linked list will be covered. And yeah, if you find this channel useful, do subscribe to it. It helps me keep motivated. Do like this video if you learned something new, and also let me know in case of any queries. Take care. Bye bye.